This video begins where Part 4 left off, and will primarily focus on incorporating a system that will randomly spawn asteroids when the game starts. As with the rest of this series, you can find a written version of this walkthrough in the description below. Begin by creating an empty game object named Asteroid Manager, and then creating an asteroid spawner C# script that will eventually be attached to our Asteroid Manager itself. Include a public game object variable inside of the asteroid spawner class to represent our project's asteroid prefab. In the start function, I'm going to write a for loop that will run 14 times and instantiate a new instance of the asteroid prefab each time. Each of these new objects will have a random location within that game space between negative and positive 140 for both their x and z values. But since we want to keep all the objects in the scene on the same y-plane, y should always remain 0. The asteroid's rotation will be reset in asteroid.cs's start function, so we can just temporarily set its rotation in this function to quaternion identity. After attaching this new script to Asteroid Manager and dragging the asteroid prefab into its asteroid field, you should be able to see that the scene now contains 14 of these obstacles when the game begins. Currently, asteroids can spawn dangerously close to the camera, creating an unfair and unpredictable disadvantage. Ideally, we'd like each game to have some chance of success. In Asteroid Spawner, we can add a few checks and corrections to an asteroid's location if they are initially placed too close to the camera. I think of the danger zone around the camera as 4 subdivisions defined by x between negative 30 and 0, x between 0 and 30, y between negative 30 and 0, and y between 0 and positive 30. An asteroid can be in 0, 1, or 2 of these zones upon creation. We'll start our spawner's check process by seeing if x is between 0 and 30 and reassigning its x value to a random value between 30 and 140. This same check will run on x values between negative 30 and 0, and x positions will be pushed further away from the camera in a negative direction. Z values will be monitored in a nearly identical fashion, so you can copy and paste the work we just did for the x positions and switch the references from x to z. Don't forget to switch the replacement locations x and z float values. It's important to have 2 distinct if-else statements for x and z because we want these 2 values to be examined separately, since a spawning location can potentially fall in both an x danger zone and a z danger zone. If you test out the experience in the editor now, you'll see that at the beginning of gameplay, no asteroid is too close to the player. But the camera can move through the asteroid models if it hits one. This can be fixed by detecting and reacting to collisions between the asteroids and camera. Start by adding a sphere collider to GBR main. Let's make it a bit bigger by increasing its radius to 0.7. We'll also add a sphere collider to the asteroid prefab. The correct properties for this collider should already be calculated by Unity, so we don't need to edit them at all. Additionally, each asteroid needs a rigid body. Inside of this newly created component, uncheck the Use Gravity property and freeze all position and rotation constraints. Now that our camera and asteroids have all the components needed for collision detection, navigate to player.cs so we can add an onCollisionEnter function. Inside of this function, create an if statement that will test if the collided with object has an asteroid tag, and delete the colliding game object if it does. To ensure that these lines of code actually work, we'll create a new asteroid tag and include it in the prefab of the same name. For good measure, I'm going to add the player tag to GBR main. If you press play in the Unity editor now, you'll see that asteroids disappear on collision with GBR main. That's it for part 4, and make sure to save your progress. At this point, we're ready to move on to the 5th part of this video set, which covers firing projectiles with gaze input. Thanks for watching!